Welcome to my video lecture based on utilization of electric power. Paper code EE702. Today's topic is electrodeposition process. Electrodeposition means using electrolytic process we will separate some metals from a particular alloys. So that process is done with the help of electrolysis process. And in my previous lecture, we have learned about which laws are based on electrolysis process and how the basic mechanism of electrolysis process is going on. That things we have learned from our previous lecture. So, myself, Rumum Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandra Sur Institute of Technology and Sports Complex. Formerly, this institute is known as Dr. Sudhir Chandra Sur Degree Engineering College, and this institute is under JIS code. Let us start with our topic, that is electrodeposition process. Extraction of metal is an electrochemical process used for the production of metal with commercially acceptable purity. There are two methods of extraction of metals depending upon the physical state of the ore. In one of the process, the ore is treated with a strong acid to obtain a salt, and the solution of such a salt is electrolyzed to liberate the metal. The second process is employed when the ore is available in molten state or can be fused, and in this process the ore which is in a molten or fused state is electrolyzed in a furnace. So what we have understood, that extraction of metal is an electrochemical process basically, and it is used for production of metal with commercially acceptable purity. Because of this commercially acceptable purity, that metal should be deposited in such a manner that the amount of the non-pure elements should be eliminated. Basically, there are two methods for extraction of metal depending upon the physical state of the ore. And in one of the process, the ore is treated with a strong acid to obtain a salt, and then the solution of such a salt is electrolyzed to liberate the metal. The second process is the employed when the ore is available in molten state or can be fused. In this process, the ore which is molten or fused state is electrolyzed in a furnace. Okay. Now the process of extraction of zinc. How the zinc can be extracted. This is an example in which an aqueous solution of salt is used. The ore, consisting largely of zinc oxide, is treated with concentrated sulfuric acid, roasted, and pasted through various chemical processes in order to remove the impurities such as cadmium, copper, etc. By precipitation, the zinc sulfate solution so obtained is then electrolyzed. The electrolysis of zinc sulfate is accomplished in large lead-lined wooden boxes having a number of aluminium cathode and lead anode. That means for zinc extraction, as a electrolysis, we have taken zinc sulfate is accompanied in a large lead lined wooden boxes having number of aluminium cathode and lead as anode. Zinc gets deposited on the cathode and is removed periodically once or twice a day. The current density on the cathode is about 1000 ampere per meter square. The voltage per cell is about 3.5 volt and usually 100 to 150 cells are used in series requiring a pressure of roughly 500 volt and the energy consumption is 3000 to 5000 kilowatt hour per ton. Okay. So that means zinc gets deposited on the cathode and is removed periodically once or twice a day. The current density of the cathode is about 1000 ampere per meter square and the voltage cell is about 3.5 volt and usually 100 to 150 cells are used in series to requiring a pressure of roughly 500 volt. And the total energy consumption is about 3000 to 5000 kilowatt hour per ton. Secondly, extraction of aluminium. This is an example of fused electrolyte process. Aluminium is processed from bauxite containing aluminium oxide or alumina. That means 70% in case of high grade of bauxite. And silica, that means silicon oxide and iron oxide. That means we can get the aluminium from aluminium oxide or alumina, silica, that means silicon oxide and iron oxide. The bauxite ore is first reduced to aluminium oxide by chemical treatment and then it is dissolved to fuse cryolite. Cryolite is a solution of aluminium fluoride and fluoride of either of sodium, potassium or calcium. The mixture thus obtained is electrolyzed. The fusion and electrolysis are accomplished in a large shallow rectangular steel bath lined with a carbon and carbon anodes projecting outwards the bath and the bottom of the bath forms the cathode. The charge is melted by the arc struck between carbon anodes and cathode and is then maintained in a molten state by the heating action of the electric current flowing through the charge. The liquid metal deposits at the cathode and settles at the bath bottom and is periodically siphoned out into large ladles from which it is poured into pig or ingot molds. Fresh alumina is fed into the bath at short intervals to replace that which has been decomposed by the current and the process is therefore continuous one. The aluminium obtained by this process is 99.5% pure. Remember this, the aluminium which is got by this process is 99.5% pure. A furnace having an area about 15 square meters will need a voltage of 6 volts and a current of 40,000 ampere. Energy consumption is 20,000 to 25,000 units per ton. Almost the whole of the aluminium required in the present day's industry is produced in this way. As the electrolytic process requires large amounts of electric power and the process is continuous, so such plants are installed near hydroelectric power stations. The high temperature 1000 degrees centigrade is necessary to keep the ores in a fused state is maintained by the ohmic losses due to the current flowing through the electrodes and electrolyte. See, this is the carbon anode, these both, and here the power supply is given. This is the crust of bath with alumina preheating stage, this one. And this is the steel shell or pot. This one is the baked carbon lining into the cathode, and this is the current collectors. So this is the structure of extraction of aluminium process. Next, refining of metals. So here we are first considering the metal, that is copper. Refining of copper. The impure copper is cast into plates which are made of anodes in a bath of copper sulfate acidified with sulfuric acid. The cathodes consist of sheets of pure copper which are coated with graphite so that the electrolyte deposited of copper may be easily stripped off. When the current is passed, the copper ions are discharged at the cathode and are deposited as pure copper, while hydroxyl ions discharged at the anode bring an equivalent amount of cupric ions into the solution. Thus, there is a transfer of pure copper from the anode to the cathode, while the impurities like nickel, zinc, and iron pass into the solution as sulfates, and impurities like gold, silver, which are not affected by sulfuric acid. Copper sulfate solution settles down as the anode sludge or mud. At rectangular intervals, the deposit is stripped from the cathode and the anode is replaced. Copper extracted from its ore, known as blister copper, and is 98 to 99% pure. Copper of purity as high as 99.95% is obtained from the blister copper by electrolytic process. Energy consumption in copper refining by electrolytic process is about 150 to 300 kilowatt hour per ton of refined copper. See, here a block of crude copper is deposited in a CuSO4 solution, copper sulfate solution, and this is the anode mud. Anode mud made of silver, lead, etc. And these three are cathode plates, which are made of thin copper plates, and this is the DC bus bar where anodes or cathodes are connected. And we know that the total process requires 150 to 300 kilowatt hour energy per ton of refined copper. So that is the process of refining copper. Now refining gold, very precious metal, we know. Blocks of impure gold are made The anodes in an electrolytic cell containing a solution of gold chloride AuCl3 in hydrochloric acid. Thin plates of pure gold constitute the cathodes. On electrolysis process, the gold is deposited on the cathode and gold thus obtained is 99.9% pure. For a higher purity, if desired, the metal may be put to a second electrolytic refining. The energy consumption is 300 to 350 kilowatt hour per ton of the refined gold.
Madam, good morning.
Good morning. Third, refining of silver. Solution of nitric acid and silver nitrate is required for refining of silver with electric energy consumption of 400 to 425 kilowatt hour per ton of refined silver. The process is similar to that for refining of copper. Fourthly, refining of nickel. The matter is first roasted and treated with dilute sulfuric acid at 80 degrees centigrade to remove the copper. The residue, consisting mostly of nickel compounds, is made the anode in a solution of nickel ammonium sulfate. Iron plates are made the cathode on electrolysis nickel deposit plates. The energy consumption is 2500 degree to 4000 kilowatt hour per ton of the refined nickel. Fifth, refining of lead. The desilvers lead can be purified further by electrolysis. A solution of lead fluorosilicate PbSiF6 or hydrofluorosilicic acid, that is H2SiF6, containing a little gelatin. The desilvers lead is cast into anodes, while the cathodes are sheets of pure lead, and gelatin facilitates the formation of coherent deposit of lead at cathode. The metallic impurities which are more electropositive than a lead, such as iron and tin, go into solution, while the rest of the impurities are thrown down as the anode mud. The energy consumption is 100 to 120 kilowatt hour per ton are refined LED. Next one is about refining of zinc and refining of iron. The crude ore is roasted and leached with diluted sulfuric acid. The resulting solution is purified from elements present such as copper, cadmium, silver, cobalt, antimony, arsenic by treatment with powdered zinc with ferric hydroxide. The solution of purified zinc sulfate is then electrolyzed in large concrete tank lined with lead or rubber using chemically pure lead as anode and aluminium cathode. The electrolysis is carried at 35 to 40 degrees centigrade using a current density of 300 to 400 ampere per meter square and a cell voltage of 3.25 to 3.5 volts. The zinc is stripped from the aluminium cathodes and then melted down, give a metallic of high purity 99.99% zinc. 7th, refining of iron. In case of purification, the iron ammonium sulfate is used as electrolyte and the energy consumption is about 1000 to 1600 kilowatt hour per ton of the refined iron. So that's all about the extraction of metals for today's class. And from the next class onwards, we will continue about this topic and definitely we will cover this of remaining portion of this chapter, that is extraction of metals. Thank you all for listening my lecture.